It is such an honor for me to be here today to present the great professionals are here with us today in this session called Best Infrastructure Case Studies. We are, as you know, we are witnessing a major shift in the industry with digitalization as the center of the discourse. The BIM, usually associated to the field of the building, is taking a special place now in the civil engineering and the infrastructure. And in Spain, some of our leading companies in the sector at the international level, most of whose principal incomes comes from infrastructure projects, are also taking important steps toward a change in business model, one more transparent, more efficient, and more collaborative. Examples of these are initiatives such as the project Road BIM, led by Sacyr, and with the participation of other innovative companies such as TIPSA, Applitop, or my team, Apogea. A project support by FEDETI and the European Union by FEDER funds, in which we are developing BIM standards and technologies for code validation and management of road construction projects. This project is addressed from the creation and use of open BIM formats as an instrument to ensure interoperability between different actors and tools, and therefore we coordinate with other countries through Building Smart International as members of the IFC Road project within the infrastructure room to shape the extension of the IFC format in the field of roads. In order to speak to us today about being in the field of infrastructures, the digitalization of the industry, and the changes in the business model, we have today three important references. David Morton from Northumbria University, Christophe Castain from Building Smart International, and Jacob Wachocki from Bentley. As the first speaker, it is a pleasure to introduce you to David Morton, relevant research into digital praxis in the exploration of design from Northumbria University. Welcome.
Hola, thank you very much for having me today. What I'm going to go through is some case studies and some experiences in terms of research we've been doing at Northumbria, what we call digital heritage, and look at the way in which we can use BIM to capture and benefit the people who look after the beautiful buildings we have all over the country. In terms of the research team for this particular presentation, I'm very fortunate enough to have some fantastic colleagues, and I need to name those, James and Danilo. We have, over the last 3-4 years, explored BIM, but then moved out towards the edges of BIM and looked at the way in which we can use BIM to capture what's already there. We've heard a lot today about how BIM can be used to scan and record. But it's often to do with existing buildings or new or contemporary buildings. What I'm going to focus on today is more historic buildings of that nature, and how we can look at those, capture the detail of those, and use that to move forward. So in terms of BIM and options for managing buildings and data capturing, that can be a long gestation, a long process in terms of how we do this. What methods do we use within BIM? There are an awful lot of apps and processes and that kind of thing. So it's a huge arena to explore within BIM, let alone architecture and facilities management. And in terms of utilising BIM, it brings the if you like, the light bulb moment a little bit earlier in the process. It affords a quicker resolution to options in terms of how do we capture the data, how can we use the data, and more importantly, what data do we capture and how do we capture it to get the most out of it. It's fantastic. I'm sure I'm of an age now where I've got my music on vinyl, I've got it on digital, I've got it on CD, and I've even got it on memory stick because I'm quite hip in terms of different systems to use. But each of those are great, and they have been great during the lifetime of those. But each one has got outdated, and sometimes there's a particular point in time where it's no longer usable, it's no longer accessible. And what we've looked at with this research is how to utilise the data and how to capture it in a format that lasts the longest and allows us to have those moments of intuition when we think, let's go and try that out, let's go and try this avenue out. And no door closes. In fact, more doors open throughout the process. So in terms of what I'm going to talk about, hopefully for the next 15 minutes or so, is looking at changes in terms of perception, eBIM, scan to BIM, heritage BIM, and then focusing on the case studies, those three main timelines there, and then with a little clock at the end, hopefully being on time about 10 or 15 minutes. So in terms of BIM, to give you some context, often, and we've heard today again, like I've said, it's to aid construction of a new process, to support and encourage collaboration. And in terms of improving efficiency and accuracy, that's a really important one that I'll take all the way through. Also to reduce waste and cost. Now that's applicable to new build, as we've heard today, but in terms of heritage BIM and digital capture of heritage, that is also really important. And I'll go through that in the case studies in the later slides. In terms of developing rich models, we've heard about that again today. But again, in terms of heritage BIM and scan to BIM, there's opportunities within this environment to capture huge amounts of data at fantastic levels of accuracy that we've never perceived before. When I was a student a few years ago now, or 20 plus years ago, I would never have thought we could capture buildings, existing buildings, to the level of detail that my students catch now when they're scanning buildings for projects. We're down to millimetre accuracy. I was lucky if it was kind of down to the 50 millimetres or that kind of thing. There's a level of accuracy that's really ramped up, and that's fantastic. In terms of the new builds, like I say, it's not all about new builds. In terms of BIM, the UK is slightly ahead of the game. In 2016, we put into place all the new approaches in terms of construction, but that again was for new build. Not a lot of it at that particular time was for heritage build or older buildings. But again, that's unfolding, and I heard more and more about that today, and I was really pleased to see the keynote speaker talking about the idea of capturing older buildings and utilising those. I mean, what we have and what we have around in many cities around the world are some fantastic buildings that get forgotten, they get unloved, they get unused. And there's a chance here to kind of turn that on its head and look at a way in terms of utilising those accurately and successfully, again using BIM. In terms of eBIM, we've heard a little around that as well, in terms of providing information to architects, engineers and contractors, making sure that we're all on the same page, not only on the same page, on the same paragraph, down to the same word, probably down to the letter. And that's really important. And we can do the same kind of thing with heritage in terms of capturing older buildings in terms of levels of detail. In terms of the hard copies and all the information that goes around between teams as well, we can also short-circuit that and be very, very efficient in terms of how we design and how we go through all the processes to look after the buildings we have. And what we end up with and what we generate from this is the model itself, and then from that we generate all the pictures, the views, the sections, the elevations, and we abstract them. Whereas we would have done it the other way, we would have done it longhand before. But we have the chance here to abstract from one source, as we've talked about before, and that's also really important. On our own campus, we've done what it says in the tin. We are practicing what we preach, as it were. Our own campus has been fully scanned, and all of our buildings are now on a kind of digital campus. So we can look at ways of looking at energy consumption, even down to looking after the things like we talked about this morning, the cleaning, the painting, that kind of thing, the maintenance. You can imagine every day we have hundreds, thousands of students going to hundreds and many hundreds of lectures. Now, if one thing goes wrong, there's a huge repercussion. So on campus, we've got this as a management tool. But that can be used in terms of heritage as well as a management tool for looking after the buildings. So it's no different. In terms of research, there's very little in terms of looking at BIM in terms of heritage buildings and cultural landscapes. in terms of traditional ways of documenting heritage buildings. I'll show you the next slide. It's quite shocking, actually, and quite amazing what little information some people and some English heritage and so forth, and all other the big players that look after our heritage, they have sometimes very little information, very inaccurate information about the very prominent buildings. In terms of techniques to bring that forward, to scan to BIM and so forth, it's been an absolute godsend. I'll give you an example. In terms of heritage BIM, okay? Now, the picture you see there, that isn't a photograph. As you've probably seen lots of the really whizzy pictures this morning going around various buildings and cityscapes in terms of transportation systems. Absolutely fantastic. And again, the level of detail captured is amazing. But this is a scan that we took of Durham Cathedral. You might recognise it. Some of the apses of this particular building were used on the film Harry Potter. In terms of the information here, a lot of the building there were unknowns in terms of what was already there, what actually still exists compared to original drawings, original plans. Hardly any elevational drawings, mainly plans, and they were very, very basic, which you'll see in a second. And this allows us to capture a huge level of detail in terms of the building itself, the proportions, down to millimetre accuracy, like I say, but also looking at the condition of the building. In the UK, we have quinquennial surveys. So every so many years, we will survey various historic buildings and say what condition they're in. Is there any maintenance to be predicted, or is there any maintenance that has to happen immediately, or over a 5-year, 10-year, 15-year period? And that was based on a small team, sometimes a very, very small team, going around the building and assessing it by eye, and just by experience, saying whether something needs doing in that 5 or 10 or 15 years, like I say. Now we can scan this particular building and various elements of the building down to millimetre accuracy and say whether we've got erosion, we've got issues with the building at levels of detail that we've absolutely unheard of before. Again, in terms of scan to BIM, again, similar in terms of measured surveys, it allows us to scan the building and tell the client if they wish to have various stones replaced, we can give them an accurate to millimetre accuracy drawing of a particular piece of the building itself, bit of stonework or whatever else, and tell them where it needs to be replaced, how much of it needs to be replaced, the shape and form of it, and that drawing, that point cloud data can be made into a drawing and then sent out to be made and put in. But with the benefit that when the craftsmen come to site and fit this bit of the new bit of building, the bit of stonework, it fits like a glove. It's a bit like architectural dentistry, you know. It allows you to put things in absolutely perfectly and hopefully give the building a smile. In terms of our surveys and the research we're doing, we're finding more and more people are wanting us to do more citywide scans of various bits of the city to look at different ways of implementing new road structures or different ways of routing pedestrians like we've seen this morning. An example again, outside of the Durham Cathedral. There were various elevations on this particular case study that suffered really badly from erosion due to traffic and so forth. Before, it was a bit of a kind of a go there, check whether that particular elevation is suffered anymore over a shorter period, so every 5 or 10 or 15 years, but if it's looking particularly poor, they would go back every 6 months, every couple of months, that kind of thing, and monitor it. Now, with the scans that we've afforded the client, they have accurate surveys of every elevation, and we can tell them and predict far more accurately with a very fine grain of information that we have when particular facades will need doing. We can actually say, okay, within 3 months you need to do this is critical. Within 4 or 5 months you need to do this. And that budget you have there, don't worry about that, because that elevation actually doesn't need doing. Looking at the erosion over the last 2 or 3 surveys we've done, you don't have to actually spend any money for another 18 months or 12, whatever else. So the information is extremely data rich in terms of what the client can glean from it. In terms of the scanners that we're using, I know this improves all the time. It's the same kind of thing with phones. Typical scanners that we use now, we have 1 million points of data, and it just takes 6 minutes. I mean, that's unheard of. I mean, in my lifetime, that's gone from kind of the measuring tapes that were in, you're kind of like pulling the tape, and if the guy was really heavy on one side, the tape might stretch a little. She might be a little bit further out one elevation than another, and you work out why on earth that elevation doesn't quite fit when you go back and do the CAD. Now we don't have that. It's a case of, it gives us fantastic levels of information, and then 1 point of data, for example, on that third point there, 1 point of data every 3 millimetres, so we can be that accurate. In terms of a process, this has been talked about this morning, so I won't go on to this too long. Very simple, scan process, sometimes in some elevations down to literally minutes, 6 minutes for some of the elevations. The process itself, take it back to the lab, start to process that, get that into a digital model, and then give that back to the client. Well, what we do is we talk them through the model. We allow them to understand what they've got. It's a bit like the good old days when you just had the 2D information. A lot of people, a lot of clients can't read drawings, and we forget that. We're part of a team, a larger team, that we could share drawings, we could talk about pictures on the screen, and we all know we're all there. A lot of clients can't do that. And when we do the model, when we produce the model and we talk it through, it's amazing how clients who thought they knew their buildings understand it at a far greater level. That's a great bit of the process. And in terms of examples, I've put on a QR code for you. So any of you have got the QR code readers, you can fire it to the screen and watch this. I don't want to play that today because I was a bit concerned about the time we might have for the presentation. So if you wish, you can I can take a picture of that and then scan it later. And that shows you one of our little movie clips. It's about 6 minutes. And it shows you our process and how effective it was in terms of delivery to the client. So like I say, at the bottom there, we have the scan of outside Durham Cathedral. We have the plans, and then top right there we have the, I hope to think, what lovely pictures in terms of sections and detailed information about the building that the client never had before. I'll give you an example. That's what the client had before. When we went to Durham Cathedral, that was pretty much the only information we had. And some of those drawings, I've actually scanned that, some of the drawings were on parchment. So there's a big time scale there in terms of misinformation. It's a long, long time ago. And what we do now, we scan and we produce this kind of information. And a lot of us do this now. But all of those points that are starting to come up on the screen, little circles, were critical points the client never knew were a problem in their own backyard in terms of facades needing remedial work, stones needing replacing, that kind of thing. And that's a great thing in terms of capturing and looking after our digital heritage. And again, you saw the picture inside the building. This is a scan outside the building, and again down to 3 millimetre accuracy. So the client not only has elevations, but accurate elevations, very, very accurate. So it's a physical recording of condition and for preservation and maintenance. And then creating not just elevations of the building or parts of the building, detailed elevations that allow for studies to be done and data to be captured in order to maintain. That's a lot more important. That's really important to think about. The data that allows us and affords us the chance to maintain correctly. Not just look at a drawing, compare it to the building and make a decision. This information allows you to make that decision straight off the bat. And again, in terms of external. And once you've captured that geometry, you can add further information. So in terms of this particular part of the building has various acoustic additions for services and so forth. And we can track all of those, we can track all of the lighting fixtures and fittings and so forth, and give the client, and we have done, give the client a database to assess and look after their assets within the building. And in terms of condition surveys, so doing something very simple, doing a kind of a see-through AXO of the building and then colouring it in terms of what to look at in 5 years, what to look at in 10 years, and what doesn't really need looking at for 15 years or so. And again, from that model, generating sections, elevations for potential structural works and accurately recording those. So that when somebody comes back, if it's a different team, a different company, a different structural engineer, whoever it is, they have records there. You can just pick them straight up and start from the same. So if you're picking up the book and you're picking up from the same paragraph, the same page, the same sentence. And also, in terms of that data, bringing it to a device that the client will want to use. We've noticed this a lot with the research we've done. It's great to provide the information, but then there needs to be a device to hand that over to the client. So more often than not, and I'm sure I've seen loads today, we all have iPads and phones and all sorts of things. To give the client an iPad, they can walk around the cathedral, any project we've done, and allow them to flick through the various bits of information while they're there. Again, there's an immediacy there. There's a level of detail there that I think BIM, Heritage BIM, and everything else we do really benefits the kind of cultural heritage of what we have around us. And some case studies, just a kind of heads up, and what we found that works. First one, Sydney Opera House. In terms of this particular case study, what we did, we were lucky enough to win this particular scheme, and we created a full information system that's now embedded in all the operational methods that they use for the building to allow for cost efficiencies, to support kind of the visitor experience. It's a bit like with the campus, keeping everything running and keeping everything running very sweetly. The whole thing is constantly maintained. So we have a geometric accurate model, but like we've said today, it's great to have, but then we have to make sure that we maintain it. So in terms of that, we have an accurate model that is maintained via us at a particular point. So when they know when they're going to do any alterations, and we record those and capture those. And in terms of what they class as, the client call this stress testing. In terms of potential existing or proposed future systems, operating systems, we can add those into the model and test them in terms of heating, cooling, load, and that kind of thing. Will they work? Won't they work? So that they don't have any issues and they have minimal downtime. And then our own campus, Northumbria campus on the estate, we used it to explore and analyse the carbon emissions across our campus to minimise those. To look at the intelligent models across campus so that we have an accurate resource for creating additions to the buildings, changes to the buildings. I mean, I've been at, I'm sure you all have, at various places you work. If you work there for more than 2 or 3 years, you will notice how many times things get changed. I mean, I've been at Northumbria for 8 years. I've moved office 4 times. But in terms of that date, that transition, we've used the model to make sure that not only is the maintenance done on time, but people like myself who work in the university know where we're going, how long we're going for, and that's all charted on the model as well. So in terms of a benefit to the client, it's massive. In terms of full management of all the business critical systems, so we use the same model again for making sure that all of the lecture theatres are used most effectively and efficiently, and if there are any issues, to log those and make sure they're done from one source. And we talked about Durham Cathedral. So in terms of that particular case study, that was the bespoke model, scan to BIM, and all the ancillary buildings. That was to create a full detailed resource in terms of fabric condition, specification and management of the buildings. And in terms of an accurate condition survey. So the guesswork, or accurate guesswork, but guesswork over 5, 10, 15 years on the quinquennials and surveys is now scanned down to 3mm accuracy and planned far more effectively in terms of client spend. And then the final case study, on a bigger scale, actually ties in with the keynote today. Newcastle Gateshead. Many cities have the issue where you have brand new projects and you want to take out a part of the city and put in a new building. How many times do we have issues where people will stand up in a planning meeting and say, I don't believe that building's that high. I don't believe that building will do that, and it'll actually overshadow my building, or this will happen, or that'll happen. What we've done is accurately model the city to allow for any projects to be modelled within the virtual model before the physical is made. So there's a potential there for kind of swift and easy interaction with testing of those. And also in terms of looking at future potentials in terms of digital analysis of different processes and planning and urban design of the city. So finally, to sum up, we've talked about the idea of scanning. So you go from, on that slide, to get the right way around, from the right to the left. So you scan to kind of create new buildings. So you can scan to afford accurate new build projects. But what I reckon, in terms of where potential new chapters are starting to open within BIM, is the idea of capturing accurate and effective future, what I call curation of buildings, to allow us to have models that we can accurately afford to finance and program looking after what we have around us. Thank you very much indeed.
Thank you, David. And now, as the second speaker, we have Christophe Castaing, Director of Digital Engineering Aegis and Chairman of the Infrastructure Room for Building Smart International.
Okay. Yes, one thing about my title, that I was in Aegis since 30 years, maybe more. And I work on the both sides in terms of software development in first part of my career, and secondly in project management of big project. And then I come back to the question of BIM at the end of my professional life. And I also involved in project of research and deployment in France and outside Aegis with Mind and with Building Smart. I'm coming back to in my presentation. BIM now Aegis is a company of engineering consultants, around 1 billion of turnover per year, now more, and 60% of our activity is not in France. But in BIM, what does it mean today? That means all of our crucial project, major project, are under BIM, all of them. That means that today is not less than several dozens of billions of euros of works managed by Aegis under BIM. So BIM is not the future; it's really involved. So what I'm going to explain is, first of all, what are the processes and the principle of BIM we are using, based on our experience as professional, but also part of the development about the research on BIM, and I'm going to explain two business cases. One about the motorway in Marseille. We won the first BIM award for infrastructure project in France with this project 1 year ago, and the project about Société du Grand Paris, which is one of the biggest projects of the world for railways. It's more than, for itself, only for the part of the railway, it's more than 25 billion of works together, not less than 21 tunnels under Paris for the next 10 years. So our approach on BIM is oriented around the question of BIM execution plan. We're familiar with that, and when we say that, is we are mixing two references. The first one is the ISO 19650, which is not already approved in ISO, but it's mainly based on the British standard 1192, which is important to note. The name of that is information management using building information modeling. So everything is important in the title. And we mixed also with the approach we have in the Penn State in terms of developing a BIM execution plan. So it's interesting to merge the both. I'm going to explain why. And what is important in the BIM execution plan, and that is totally based on the pain state, is the 4 steps. The first one is to identify why we are using BIM. Full BIM, we have some in some terms of a reference, you have these requirements from the client. Full BIM. I don't know what does it mean, full BIM. Nobody is able to say full BIM. What does it mean? So you have to identify, according to your project, why you are using BIM and for what. In other terms, identify the BIM use. Because BIM use means also added value according to the process and so on. Then you have to describe the processes by themselves. And then to develop how you are going to exchange the information. And then that, in this part, you have to, that's the way to mix, and we need to mix a British standard or ISO 19650 with the pain state. And then to define how you are going to work, the infrastructures of the BIM. And the keywords are the following. The definition, which is the definition in the ISO standard, use of structured data and information. Data and information. To support the delivery of a project and operation of an asset. The delivery of project and operation of an asset. That means that I come back to that now in our activity we are going to deliver 2 things, 2 assets. The real one, that we are the construction, and the virtual one. That means that the delivery of BIM, it's also a value. It's also a delivery. It's also an infrastructure to be managed. And that means that the information system has to combine 3D models, and I'm going to correct that. It's not 3D models. It's 3D object model. Very important. Why? Because it's a way to associate semantic, workflow, and other information. And processes. How we are going to deliver. One remarks about that, the delivering. Until now, we can say that in our activity of designer, we are going to spend not less than 20% to reissue drawings and documentation, to reissue, for several reasons, but to reissue. So we are spending 20% of the activity not on design, but on drawings and documentation, 40%. Plus around 10 to 20 to verify the quality of the information we are going to deliver, or to be accepted, or to be issued. So if you make the calculation, the real engineering is less than 50% of our activity as designer or as a consultant. That's important to, and that the main reason we have to develop the processes around BIM is because we need to develop more added value in terms of engineering regarding the question of the development of the information and IT information. And what is also important that is to consider that BIM is not outside the process of the design. And this schema coming from ISO 19650 is the key one. You have the ISO 9001, which is the core of our activity. And you have your QAQC inside that. And we consider that BIM, through ISO 19650, it's just a part of that, inside that. That BIM is not outside. It's not something more. It's totally embedded in our processes. It's really the philosophy of ISO, and we are really supporting this approach. And the second thing is crucial, really important, because everything I said has related to that, how to decrease the cost of delivering and how to be able to have more discussion, more co-design, and to go in the direction of the famous Patrick McLamy curve, to say how to be able to make all of the modification very early in the process. It's the question of common data environment. And in the common data environment, you have, two key concepts. The first one is you have to develop your own activity for you, and then you have to decide when you want to associate your information with the others. So you have two concepts about that. The question of workflow management, that means work in progress, fit for coordination, fit for approval, and so on, so on, so on. That's a concept. And the second concept associated is the question of shared space. That means that you are going to share the information, not to deliver, not to spend time to create drawings and so on. No, you are going to create this space to share with the other stakeholders and so on, to have this discussion about the acceptance and the communication. So on the left part of the slide, you have the approach of the ISO. On the right side is an example of how we are developing the CDE in our project in Aegis based on the authoring tools you have on blue on the right part of the schema, and the share space on the left side. And I'm not going to make too much advertising for Bentley, but in our case, we are deeply using a project-wise to be able to manage at the same time the share space and the workflow. Okay, so in Penn State you have to develop the BMUs and the process map associated to the BMUs. Why I want to develop that? Okay, I'm going to come back because I think it will be too long if I explain more there. So a key moment of this delivery is a question of the project review. So to develop a project review, you have to develop the process around that. What does it mean? That means that you are going to there is a problem on the slide because tant pis. Normally there is an animation with different slides. Okay, I wanted to show the different process of approving, modifying the workflow. I am a work in progress. In my QA/QC, I have a project review or model review. So if I agree with the content, I say, okay, now it's fit for coordination or fit for validation. I change the workflow. I maintain the name of the file because it's a way to say my file, my information is unique. I am not going to communicate that. I share that, and the information is unique. Okay. And why it's important to say that? Because one of the typical requirements you have in contract like FIDIC is to say that we have to maintain the records of the evidence. Don't forget that BIM is under a contract. And the question we are trying to solve with BIM is a question of the responsibility, the question of who is the owner of the information, we have the responsibility of the design and so on and so on. And we have to maintain this information. So BIM is much more than the question of geometry, 3D, and so on and so on. It's your responsibility, your contract management. So briefly, to use case. The first one is an example based on the motorway in Marseille. So going to make. So I need to explain that. So the idea of the project review is to orient it through an integrated model all of the project, to be able to first to analyze that through clash detection, for instance, then to analyze the clash detection, to organize that, because clash does not mean nothing. For instance, if we have a clash on a pavement, you want to have the clash, you want to have that to be connected. But sometimes you don't want that, you want to have a space. So you have a several way to manage the clash, because you have when you load a clash detection process in, for instance, Navisworks, you obtain thousands of clash. So you have to organize that. Then to report, important to report, and how to report, and then to report this information not only on the design team, but also in your CDE to aggregate to your model and to your design all of this information related or what is the problem and so on. So just to prove that's the example. So you have all of this in 2 minutes. You have all of these steps about that. First of all, you on the right, you describe the information model by model, and what is very specific in infrastructure. So you have also to describe the space organization, not only and you have a huge number of models. And just I'm going to stop here because everything is perfect except that. Not except that, but it's mainly that. Okay. You have here, I try to stop, please. Okay. Well, okay, the picture looks good, except that if you have a look about this information you have here, in French mean cross-section number 12. So how this information is coming? That is a big problem, because we create this information inside the integrated model, because we are not able to extract directly this information from the operating model. There is another one information missing when you are using eNavigator, Navisworks. There is no counterexample of that. There is no so integrated tools like Navisworks or equivalent in the world able to provide this key information, where I am. Not on XY, because we don't care of XY. Where I am in terms of station, chainage, and offset. There is no tool able to do that. You have no tools. You have this information in Civil 3D, you have the information in Power Civil, but when you are the integration of the model in Navisworks, you are losing this information. Okay, that's the bad news. Good news is we are testing in Barcelona 1 month ago. We have the presentation by Autodesk, Dassault Systèmes, and Bentley, that through IFC alignment, we can say that next year you will be able to manage this information. It's a software. Okay. And the second things we are also where we have a problem is the second one. You detect a problem or a conformity, and you create a viewpoint. You have on all of software like Navisworks, you have this functionality of viewpoint. The question is, this information, which is crucial because it's a contractual information, how I am able to keep this information and to associate that to the model. You have one possibility with BCF, but it's only one, and this information cannot be associated directly in your common data environment. But it's your contract management. That is a big difficulty, and it's not solved today. Okay. And just to underline the importance of what I'm saying, because when you are designing, we are using this V process, which is coming from the manufacturing industry, to say when you create something, you have a V process. On the left, you have the design, and on the right, you have the commissioning or the handover. And what all of the information I mentioned in terms of workflow, in terms of clash detection and so on. Why it's important? Because it's a way to prove that you are compliant with your program. And when you arrive in construction phase or during the handover, you need this information to verify during your handover you are still compliant. That is very important of the continuity of the system. So I come back to the second business case. I'm going to speak about the infrastructure, railway infrastructure. We can say that today, and not today, it will be the same tomorrow, that it's a more difficult things to build in the world. To create a plane, to create a car, is much more easy than to create a railway network. Much more easier. Why? And you have this explanation. Because when you create a railway network, you have to manage the infrastructure, the civil works, but also the bridges, the station, you have to manage the huge information called environmental issue, bigger than even the design information, bigger. And it was not managed by the CAD system, they are managed by GIS. And you have also to manage all of the systems, rolling systems, connected systems associated to that. So the question of how to create this common data environment is really a difficulty. And it's what we are going to do with the Grand Paris. Going to go as fast as possible for that, but you have a picture of the complexity of the problem, of the interface, and so on. And what we are doing about that is to define what it is not done at the moment about how, in any case, it's coming in some industry you have this information, but not in the construction industry. The question of how we have to modelize these systems. Systems could be the earthworks, that is, we know that because it's earthworks, but for instance, everything related to the connected object, which are already part of the railway system, are to be modelized and to associate to the civil works. Tunnel, we have a problem, and that one of the tasks we are going to do is Grand Paris is to create data dictionary for all of the equipments related to the railways, in order to be able to prepare the schema for the extension of IFC, but also to be able to connect this data dictionary and object type libraries to the catalog coming from the manufacturing industry already here in the world of the railways. And what I mentioned that is because in the scheme here, I mentioned that on the right part you have IFC. Everybody knows IFC, but on the left part, but on the right part you have the called TC242, which is a standard based on STEP, which is deeply used by the industry for all of on the aircraft industry. They are using that. But if you are speaking about Alstom, or with Thales or SPI, they are working with this kind of standards. And we don't want to recreate 3D information because they are already building their technology and their object with this 3D technology. And the problem is now crucial, how to be able to integrate all of the information on a unique common data environment. So we're going to conclude with that we are working on this question of information asset management. We need interoperability to be able to do that. Interoperability from now, how I am able to discuss from me to another one today. But the important is not today. The important is tomorrow. What is going to happen in the next 25 years or 50 years about this information, about this interoperability, if I have not the standardization? And the quick question for the owner now has to be not if I am able to provide a BIM model today. Normally they have to ask you, are you sure that I will be able to reuse this BIM model in the next 50 years? That's the reason we are developing in Belux Smart this roadmap around IFC rail, road, bridge, tunnel, and maybe a geotechnical issue with the perspective of 2021, something like that, with IFC 5, but not only on IFC, also with the OGC. We are developing the GML standard for GIS part of the project, and maybe also with what it is already existing in the railway industry, like a right topo model, plus what is existing in the manufacturing industry, like step 242. It's just to conclude in one word. We have some meeting with the Boot Aerospace, which is a venture of the main industry of around Airbus, and they said to us two things. they are going to unify around CATIA all of the information around the design. They say that. But they say at the same time, and because everybody knows that the key problem they have with Airbus, with the Airbus 380s, the disaster they have with that is because in France and in Germany they were not using the same release of CATIA. Okay? So they say now everybody is going to use CATIA release 6. But they say we are going to do that under one condition, that all of the deliverables are to be available under the format STEP 242, not under Dassault system format, under an ISO standard. They say this first thing. And they say secondly, it's your job as the construction industry to develop your own standard. And you have to learn that Dassault Aviation is saying to us that don't take care about Dassault system. They are not able to develop your standard. Do it yourself. Thank you very much.
Thank you very much, Christophe. Okay, and the last speaker we have today in this session is Jakub Łukaszoki, being consultant, advisor, and lean business transformation advocate from Bentley Systems. Thank you.
Not 30. Okay. I've been told 30, so I will be rushing. Bueno, pues puedo empezar en español, porque un poquito me lo acuerdo. Gracias por a los organizadores por invitarnos aquí. Bueno, yo trabajo en Londres, pero quiere decir que soy polaco, pero no el de Barcelona. Y bueno, soy consultor BIM de estrategias digitales de Bentley Systems. Me ocupo de la transformación de las organizaciones y yo creo que tenemos que hablar de estos números, porque más o menos 10% de la transformación digital es relativa a la tecnología. Lo demás es people, process, policies and organizational change. Okay, so I will now switch to English. I think it's a bit better for you.
Very good for me.
Yeah. Okay, a bit about Bentley Systems. So we are a global company, around 3,000 employees, and our portfolio spans from different industries. Water treatment, infrastructure industry, obviously building, plant and manufacturing as well. And if you look at the built environment as such, obviously buildings are just a component of it, and we need to look at in a comprehensive manner to be able to approach, especially when you talk about infrastructure project. This seminar is about the infrastructure project, so I thought this would be very relevant. And also a little bit about how do we approach the digital transformation. When we maybe very briefly, I will skip a little bit here, but it's all about being able to be successful. Going in the right direction, so we need to start with our appropriate strategy. We need to be able to have success in the implementation itself. So once you devise the strategy, you need to have a certain success in implementing what you've planned for. And the other element is the people-human element. And we have a program that we've developed with Crossray, but actually now we're we're building another one in Malaysia and in India. and also in the United States. So it's a program, it's an academy for enabling the supply chain to actually leverage the processes that the owners devised. And this is just very briefly another hat of mine. I'm involved in the industry, and this is an organization we've created recently around process innovation, and we look at connecting the biggest inefficiencies from the industry with the potential solutions, and those might be technological, but might be process or methodology. Okay, so I will do a very brief, maybe I will skip this because those numbers are known, and maybe go to the Jews, but just to mention that there is a big opportunity in the industry. Everybody knows that, well, at least the government, most of the governments know that. There is an opportunity for huge savings in time and money. And those were the numbers from FIATEC, which is a United States organization, and these are the UK numbers. And those are the targets of the UK construction industry to be achieved by 2025. So, you know, seven and a half years left, they see that those numbers are achievable. And we also have a little bit of a wow factor as well. A lot of different technologies. Cloud computing coming, we've been talking about it a little bit. Social networks, obviously Internet of Things and virtual reality. So there is a bit hype in there. And when we talk to the owners, you say, okay, what's your vision? What would you like your BIM or digital implementation look like? What do you really want? And the owners want information availability. They want to be able to answer their questions when they run the asset. If it's an airport, it's a rail, it's a road, they would want to be able to answer questions around their assets at any point of time. And having the availability of that information at the fingertips, that's what is driving the owners. But obviously there is a problem. And it's been stated many times that around 75% of the projects went over time, over budget. So something's going wrong. And probably if you look at the digitization index of the construction industry, guess where the construction industry is placed? Yes, you guessed it well. It's at the bottom of this list. Probably we should learn from the airplane industry and other industries. Christoph mentioned it already. But how can we focus more on reliability of your assets? Focus on being able to reduce your number of accidents. You see, in the construction, in the airspace industry, they reduced the crashes from 60 to 2 crashes per million flights, but actually only 0.3 are related to technical problems. And when we talk about BIM as well, I'll be very brief as well. Most of the time, and the first time I saw this image was actually in Maranello in Italy, where these Ferraris are made. But a lot of people talk about nice picture. Hollywood was mentioned before, but what's important for the owners is being able to utilize this asset during the operational phase. So, my question is very often, how can we move from drafting and searching to thinking? Because us as humans are made not to produce, to execute. Those things can be automated. We want to leverage our brains to its fullest potential. So we want to move people from drafting to thinking, and we want to utilize information not in that way, but in this way. In the way that's structured. Christoph again was talking about the information that needs to be structured, and he talked about things like asset data dictionaries, and which, by the way, those are being worked out already in the UK. So I'm pretty sure Christoph knows that, and there is a lot of initiatives around the globe that build the data dictionaries for specific assets. The problem is that obviously different countries have different interests. and it's a little bit political, so it's a bit of a utopia having one single asset dictionary for a specific assets. What I want to show by this image is that as you go towards the operation, less and less of the graphical information is important, and more of the data is important. But actually, I was hoping to also show you a little bit of a different angle here, because not a lot of people in the industry is actually thinking about business, about how the information and digitization will be changing your business. And the question here is, are you digitizing like Kodak, or are you rather transforming like Apple? Because Kodak was the first introducing digital pictures, digital imagery, but failed. The reason being is that he didn't leverage that technology to its full potentials, changing the business models around which these innovations can provide value. And this is why, and this is one of the case studies here, an example. I've been recently involved in Sydney Airport, and when we started their digital transformation and a roadmap, we looked at, okay, how do you make money? Where is your profit coming from? And how where are you charging? What's your business model? How can we support you being at the forefront of airline industry, and therefore also being most profitable as possible. So you've seen this before: technology, processes, and people. But when we talk about people, I would also add organizational structures. And in fact, this model is showing you that the technical core, it's important. It's obviously important. It's an enabler. But not many people are thinking about the rest, about the social parts. And again, I would come back to the number: 10% technical, 90% change management, people embedding the technology, learning, and so forth. When we talk about the digital strategies, this is and again an extract from PAS 1192 number 3 that's going into ISO as well, and it's about enabling technology, common environment, asset requirements, but most importantly the one at the top, the organizational requirements and organizational strategy. I will skip that, but again, this is an example where we work with some of our clients to look at their capability, organizational maturity. We talked about people, process, technology, and we look at devising a roadmap, and this is an example of a roadmap that's benefit-driven. Because, and I didn't hear much today about the benefits, just a little bit, also Christoph mentioned it, but it's all about the benefits. It's all about what you want to achieve by digital transformation. It's not the technology for the technology's sake. What is your business driver? How do you want to operate in the next 5 years? And such a roadmap would then obviously phase the different change. It would be split between technology, obviously strategy, and processes, and then we would look at connecting the different bits and pieces. So from the outcome that you see above to so the benefits to the outcomes, and then to enablers, because technology is an enabler. And talking about the organizational change, I've mentioned it before, the Crossrail Beam Academy. It's really where whatever we have devised in terms of the of a strategy has been then sort of exposed, and we were enabled to educate the supply chain of the biggest infrastructure project in Europe. Now will be superseded by High Speed 2, but by the way, High Speed 2 is also having a similar approach, and we are involved quite heavily in there. So processes, I'm skipping a little bit. So where is the value? You know, the research of the value. Where can you extract value, monetary value, cost value, but maybe it's safety, maybe it's reliability, maybe it's image, you want your reputation. So let's take an example of, because I've been involved in Sydney Airport recently, for them reliability is hugely important because it's the most important asset in the Australia. All the planes are coming to Australia, and it's hugely important. So being reliable, being able to provide that service, it's important. So if you look at the asset life cycle, you can see that most of the information, this is a Jackson's curve, most of the information is being produced. So you should look at it on the other side around. So the information is obviously being produced progressively. But then if you look at the value, 55% of the cost is only in the design phase and around 18 OPEX. But what we're actually looking at is around 300% in enabling a better business performance. Because at the end of the day, airport is a business. They generate money. Sydney Airport is not owned privately. It's on the stock market. Railway depends, but again, the Virgin trains for sure are privately owned. So it's about being able to generate those. So it's a process, and if you look at the different phases, and because of the time, I will be very fast. At every phase, you have certain questions to be answered because certain decisions need to be made. So it's very important to devise a process in a way that those questions can be answered at any time. And the supply chain must be able to provide the answers to those questions. We mentioned execution plan, we mentioned EIR before, employees' information requirements. Nobody talks about plain language questions. What is the questions that the owner or the builder or the designer wants to answer at any point of time? And where we looked, and for instance, very recently, last year, I've been involved in India in a project, we'll skip here. The first thing we started is what questions your operators, maintainers, cleaners. You can't imagine how much money is being spent on cleaning an airport. Huge amount of money. How can they optimize that? Cleaners don't know exactly where to go. They don't have, let's say, full visibility of, for instance, which gates are being, it's like classrooms at the university, right? Which gates are being occupied when, and so when can they go and clean? And systems can enable that. So it's all about having this visibility of information, and it's also about connecting all of the different type of information through an ID, a unique identifier. And when I talk about different type of information, I'm not talking just about 3D modeling. I'm talking business information, enterprise level information, coming from different sources together, and the common denominator of these different sources is an asset. So asset-centric approach, because asset is not just physical assets. It's Wi-Fi, so it's a service potentially. It's people to perform a service. So if you look at the in a shop, obviously the shop is nothing without people. Well, if you can automate it as well, but let's assume that you need some people, some employees to run a shop. They are also an asset. They also need to be defined. They also need to be managed. I also need certain information about them, and so forth and so forth. So again, I will attempt my own definition here because everybody does it. So for me, it's about business information management, and it's about value. And actually, if we would be able to remove this word, it's about digitally empowered business processes. Because of that life cycle, we want to look at the life cycle, and we want to look at how can you hand over seamlessly, constantly, the information from the supply chain to the owner, so the owner can make decisions. Did I run out of money? Do I need to close the project because I'm over budget? I didn't think it's going to cost that much. You want that transparency at any point of time to be able to make the right decision. So a couple of other examples here for rail. This is a high-speed 2 example where they were able to utilize the technology to obviously model the area around the rail, but also to be able to inform the communities of the impact of that infrastructure. So I'm going to skip that because you probably have heard about it. But again, it's about 4D planning, building the digital and the physical asset at the same time. Digital airports. One of the biggest examples, I think, is, or the most mature, is Abu Dhabi International Airport, where the information was utilized for construction management and for asset management as well. So there were a number of considerations and strategies around, that's the diagram that I've shown before, about conditions, monitoring, about looking at managing change within this facility, and relate different type of informations, as I was mentioned, projects, people, locations, and so forth. And the last one, which is quite close to my heart because I love curry, it's Nagpur Metro, and that was last year. We are now actually involved. Okay, I need to finish. I know. Yeah, it's if too many stupid things are being said, there is an alarm set. So Nagpur Metro, very briefly, you've might seen, and I was actually involved in devising the strategy for the governance strategy. So employees' information requirements, BIM execution plans, but also looking at asset dictionaries and so forth. And their goal was quite ambitious, taking it more than BIM level 2. And I must say that this is just a vision, because if you try to transform an industry, the whole industry, in a couple of years, that's used to 2D deliverables, you're not going to make it. It's a transformational process. You need to enable them through a number of initiatives, awareness, academy, but you also need to incentivize, and also you need to be able to create the right contractual agreements with win-win solutions, so everybody is motivated to do so. But nevertheless, they started to build on that journey, physical and virtual world being connected, it was a 5D approach, where we have the engineering production side of it. Then we had the what's the next one? Then we have the schedule integration, cost management, and finally we had the visualization of the whole process as well within the commandant environment. And this is because it was about the design, define, manage, conduct, and finally report, because only through transparency and accurate reporting you will be able to make the right decisions. Thank you. Muchas gracias.
Thank you, Jacob. I think we have just 2 or 3 minutes for questions. So you are the first, and I think the only one, because we have.
Thank you.
What level of asset details you added to the database your BIM model?
Which case study?
I mean,
Any?
tell me the highest level you achieved in any of the case study. Like what I'm very curious to know about that.
In terms of the Durham Cathedral, that was looking at all of the scans. We had the ability that anybody that came to look at the cathedral could pick out an individual stone down to that level of detail in terms of how long it had to... there was an issue that kind of kick-started all of this. They had some repair works done. As you know, in terms of stone, there's a soft centre, and they took off too much of the facade, and therefore they had accelerated deterioration of the facade on one particular elevation. And that kick-started the whole thing in terms of understanding their building at a far greater level of detail. In terms of the
I'm interested in more MEP services because like
Yeah.
the building services for maintenance
yes,
perspective. So did you attach all the database, the maintenance details, the spares? To what level it was integrated with
Okay.
the maintenance management?
for the campus itself, if you took a typical room, that would go down to the room itself, the carpet, the fixtures, the fittings, and down to things like when was the light bulb fitted and how long has it got left in terms of its life. Absolutely every level of detail in terms of fixtures, fitting, everything. The idea being that, again, like we've said, all studies have said, it's all about recording that detail and recording it at a level that allows the client the ability to make decisions at far greater levels of understanding what they've got.
And what were the cost and time that was required to
Yeah.
do this? Just a rough idea.
Yeah, the scan to BIM, we could do, like I've said on some of the slides, we could do a scan of an elevation in around about 6 minutes. So the campus itself has like a number of really large buildings that would have been difficult to survey in any other way than scan. And those buildings, I think we were told that it would take months. I think it was about 4 to 6 months to scan that part of the campus. We scanned it in about 4 to 6 weeks. So in terms of and the options that we have now that we could kind of in terms of kit, in terms of scanners, it just gets better every day. It's like phones, laptops, everything else. So
A remark on the discussion, because I think that part of the question could be re-asked in another way. If you start from the presentation done by Jacob, and we are very close to what I explained about the V process. You are speaking about facility management or asset management. The question is, because we have several contracts where we have to say, in our contract, to say, you have to deliver the information for asset and facility management. But it's not a requirement that. My question is, what do you mean?
yeah,
And you answer level of details.
Yeah.
Sorry to say, I don't know what does it mean, level of detail. I know level of development, I know level of detail, I know level of information, I know accuracy, I know things. Everything has to be already defined. And the question of asset and the question of facility are different. So the first question is, what are the requirements? And then we have to answer to the requirements. That's absolutely true that we have to, it's the reason we have to manage all the information, but according to what are the requirements. That is very important. Because we can manage a lot of details with no added value because we don't know why we manage this information. So the question of the information for what is very important to be able to answer to this question. That's the reason we are not able, as engineer or consultant company, to answer to this question if the facility manager is not participating to describe how he is expecting, what he is expecting. Sorry.
So I think I have an answer to this question because we need to know who knows. So let's ask the people who know. The maintainers of a particular asset will have a number of questions on a daily basis they need to answer. Where is my lamp bulb? Or how can I remove this equipment? What type of equipment I need to take to go and repair a certain lamp or a pump? Or those are the questions that the maintainers, operational people or cleaners need to answer on a daily basis. And you go backwards and you say, okay, what type of information I need to supply to answer those questions? You devise that, and then you ask the supply chain to provide that information at the handover stage.
It's exactly why what we are starting to do in France and some other countries are doing the same thing is a question to data dictionary and catalog. So you take an object and then you describe what you have in this object and you ask all of the experts able to speak about this object what are the information is needed. We have done this job to define a pavement. Pavement is very simple in reality. But even pavement by itself, I'm not speaking about the structure under and so on. Pavement, only the asphalt. But only to describe that, we have a matrix of maybe more than 100 lines. And we have described this matrix by lines to all of the information needed and step by step along the life cycle. So that's a job we have to do. But more or less, it's what the industry has done already. When you create an aircraft, you are not describing the object at the end.
Absolutely.
Bon. So, except that the question that it's easier to describe an aircraft to describe a railway network.
Well, this is so. I actually have a comment here because I disagree a little bit because.
Yes, but I am the client. In
Yes,
this case, I am
exactly.
the client, you know?
Because if you think about how many assets a building has, it's around tens of thousands. How many assets airplane has, it's hundreds of thousands. And how many assets a micro, hundreds of thousands. An airplane,
Yeah.
an airplane.
I mean, you are totally wrong in this case.
Oh, okay.
I mean, if you are speaking a railway, I mean, a railway if you are not a rolling stock, it's nothing. So, and if you are not able to combine the rolling stock plus the infrastructure, imagine the number of interfaces.
Yeah, those are problems. Of course, those are problems, but
It's easy. It's an easy problem.
I tell you what, I'll mediate. What it actually does is create a whole conversation that before BIM we never had. We have clients asking questions about what they thought they knew about their own building. Simple as that. And those conversations become more informed process as you move on.
I mean, I'm in my life, I am commissioning a toll system.
Yeah.
In my life, I spent some time to commission a toll system. A toll system is not a simple affair. Because you start with the beam in concrete until the back office to exchange the money with the bank and so on. So that is an infrastructure project. A road project is not the asphalt plus the earthworks. Even the earthworks is not so simple, you know, because nobody is able to know to describe what is the object inside the earthworks. So even that, but okay. So. I'm totally fed up with the explanation of the people saying that construction is simple and so on. No, compare with the manufacturing industry, it's much more complicated. In terms of system engineering, if I refer to system engineering, I say what is complex? An infrastructure project is very complex. Why? Because if you want to measure the complexity, you have to define the number of interfaces. So if you compare that, the interfaces from an airplane and the number of interfaces you have on a project in infrastructures, there is no competition at all.
But there is millions of assets in a microchip.
So we finish.
But the microchip is already inside the infrastructure project.
Thank you, three of you. And we finish here, and we have time to take a coffee and to continue the discussion. And thank you very much.